All right, people, welcome to Introduction to Deep Learning. So if you're new here, this happens every Thursday at 3 p.m. for this semester. This in person, it happens in the Weaver Science and Engineering Library at room 212. And next week, we won't have a class. So that is the announcement. Other than that, oh, yeah, if you just got here, I wanted to do the shameless plug on Data Science Institute. And Arizona Data Lab is offering a lot of these, what we call complementary courses. We are essentially teaching things which are not taught in many of the departments, not at least in this kind of a crude way. And I wanted to mention, we are now offering Cracking the Coding interview, which happens Wednesdays 2 to 3 and Fridays 4 to 5. The Zoom link is here. This is only virtual because we are using whiteboards and it's better to use it virtually. So those are the shameless self-plugs. And today we are going to talk about some of the stuff which we did last week itself. So last week, does anybody remember what we did? All right, so what am I doing? Where is my chat window? Right. Oops, can't find the chat window. So chat window, yes, okay. Chat window comes back here. We try to get access to CyVerse working. Yes, correct. And most of us miserably failed. But what was that used for? Why did we want to get CyVerse access? Because we were trying to primarily run our own chatbot. We had got this code to work in a Colab environment. And then we were saying, oh, it's taking forever. Even now it's taking forever. So let's try CyVerse. So why am I insisting that we use CyVerse, right? So the reason is, wrong window, again. Okay, so the reason is pretty much what everybody said in the chat, which is when you work with real life data and tools, you slowly realize that all these models available online from Google, Amazon, whatever, they are going to start charging you. For example, when we have bigger models like this, we need to get more powerful GPUs and memory like RAM, or even sooner, you would want to start training on a 10 gigabytes data set. So none of that is going to be free. So, or there are paid options like Amazon SageMaker and Azure. But now I was just looking at the Amazon pricing. It costs you 3 cents per page, but you can see like how fast this can, burn a big hole in your pocket, right? So as a student, none of us wants to go through paying so much money at the beginning of career, especially when you are learning. Even Azure has similar pricing, which is 50 cents per 1,000 messages. Yeah, so that is why we were thinking of, is there a free option? And the answer to that is CyVerse. So if you're new here, please go to cyverse.org and apply for an account. Since I also struggled last week with CyVerse and I'm new to CyVerse myself, today I got an expert in CyVerse. He's going to come talk to you about CyVerse and what CyVerse is, why it is a very important thing. Without further ado, welcome, Michele. You want to share? Okay, I mute, I stop sharing.
Okay. You have to mute that. Yeah, okay, cool. Well, hi, yes. Can you, okay, so they're seeing they're seeing the computer. I'm going to share simply because it's easier. Hello, everybody. Nice seeing some familiar names again. And I'm here today because I've heard that there were some struggles last week with getting things started with CyVerse. If you have not heard of CyVerse before, we are a well, now we are national and international, and now we are here at the University of Arizona, and we are here to give support for students and faculty and anybody in between with computation. But usually the question becomes, what is CyVerse and why should I use it? Well, CyVerse, I like to call CyVerse a a laptop within the cloud. And the power that comes with having a laptop in the cloud is that you are not stuck with the compute that you have. For example, if you have a classic laptop, you're probably having between 8 to 16 CPUs, maybe less probably, and between 8 to 16 RAM. 8 to 16 gigabytes of RAM, which is not bad for everyday work. But if you want to do more, if you want to do research, it is best to move out from your laptop and start using, for example, the HPC. Here at the U of A, we have a really powerful system, or use other platforms, and one of these is CyVerse. CyVerse is extremely powerful. We have always been here at the University of Arizona, but we have changed name a couple of times. We were instituted in 2008 under the name iPlant, but around 2015, 2016, when we started getting tractions, people outside of bioinformatics decided that they wanted in, and therefore we changed the name onto CyVerse in 2016. Now we have more than 110,000 users, and we are in 3 different countries, namely the UK, Austria, Australia, and the US. That's 4 countries. I can't count. I don't want to go too deep into the history of CyVerse, but I will prefer going into the website itself and show you a little bit how it works. So I'm going to copy and paste this into the chat. This is going to take you to de.cyverse.org. It's going to take you to the discovery environment. And the discovery environment is what we essentially call the wet lab bench. Onto the discovery environment's homepage, you can see how many resources you've used, how many you have available. Excuse me just a second. As well as analysis that you have ran recently, some analysis that you can instantly launch. But what are analysis? What am I talking about? Because a lot of this can become quite confusing. What if you just want to launch an analysis on something that you're working on? Okay, so what does that entice? That entices a place where you can put things, so like a data store of sorts, and 2, some place where you can run your machine or run your job, your work. Here on the left, expanding the hamburger menu, you have access to a number of tabs. What I want you to look at is the data tab and the apps tab. The data tab is where you can upload any data that you require doing research on, and you can either upload it using the upload button, or there is other software such as CyberDuck, or if you are familiar with Go commands, if you're familiar with the command line, there is more commands that you can use in order to move data around. We have a learning.cyverse.org website which discusses on how to move your data around, and I'm here just to show you which method can be used in order to move your data around. I'm copying this and putting it in the chat. So if you have time later, you can go ahead and move some data around as you please. But it's important to know that first you put data onto CyVerse, And once your data is onto CyVerse, you are able to launch any application with a specified amount of resources. Our applications that we curate are in the Apps tab. And in the Apps tab, if you click on it, there's a number of Jupyter labs, there's a number of our studio apps, as well as some desktop apps supporting Ubuntu and VS Code. For example, I would like to launch a Jupyter lab, and in this specific case, I'm going to launch the Data Science Jupyter lab, and this is the one that we curate the most, and is the safest bet for anything that we need to do. So if we were to click on the Jupyter lab, there is a number of versions that I can choose from. And for right now, I'm just going to stick with the 4.0.1. I can rename my analysis whatever I need. So right now, I'm just going to call it Mithun's secret analysis. No, okay. Mithun's analysis, then there we go. Mithun analysis. And I'm gonna click next. And here you have the ability to select how many cores you need for your analysis. For example, as you can see, if I click here, I can choose between 0 and 128 minimum cores. I strongly suggest to go between 16, 32, and 64, because 128 cores, who's really going to be using 128 cores unless you're really doing some heavy computational analysis? So for this specific case, I'm just going to select 16. Notice how the maximum amount of cores is a set 128. If you do have some analysis that you want to run and requires more than 128, I'm more than happy to talk to you. You can contact us through email. You can contact Mithun through email, and Mithun will point you to me. So let's just say that I want to run an analysis with 16 cores. Let's say 64 gigs of RAM and 128 gigs of disk space. And I'm going to click next and then launch analysis. This might take a second before starting, but this is the launch page where I can then click to go to analysis. And as you can see, I selected maybe not the biggest machine that there is out there with 16 cores and 64 gigabytes of RAM, but it did spin up in what it was seconds. So if you're not using if you do not need the GPU, just using the CPU will get you really far. And here there is a number of tools such as RStudio, the Jupyter Notebook, and even the terminal if you need to install more tools that currently we don't have installed. There is a couple of things to keep in mind, that this specific, all of the analysis that we ran are going to be shut down within a couple of days. So if you have installed a number of things here and your analysis is not done, you can just go back to the de.cyverse.org, click on analysis, and right here, click on extend time. This will allow your analysis to go further than just 2 days, but into 3 days, and so on and so on. But you'll have to check on it with it every day. Another thing that people forget to often do is to turn off their analysis, and you can do so by clicking the big red button next to your analysis. And what this will do is that it will save you computation time, because as I mentioned earlier, we were national, international, and now we are local. And although we are local, everybody here gets what we call a pro account. And pro account comes with a lot more CPU hours, but there is still a limit. For people outside of the U of A, then we request for subscriptions, and that's why you have a set number of CPU hours. However, don't fret. If you have issues with hours, we can always have a conversation, and I'm more than happy to give you hours where necessary. I have showed you how to spin up machines, turn off machines, how you can get access to apps. And there is more than we can do with CyVerse. And a lot of people that do come to us ask us for GPUs. I believe that we can give you access to GPUs, and that's why I was asking for your CyVerse username, because not the apps that we are showing here right now do not have any access to GPUs, but we do have applications which do have access to GPU power, and these can be used to train models such as what Mithun is trying to show here. So I believe that today we're going to be talking about more in depth into deep learning. So if you want to share your applications using GPUs with the people, just let me know. If not, we can train people using CPUs, and if they are interested in using CyVerse, we can still give you GPUs where needed.
Yeah, we probably don't need GPU for today, but do you want to, okay, you finish your thing and then something after that.
No, that's completely fine. There is a specific app called JupyterLab PyTorch CPU, and excuse me a second, I have to move some Zoom stuff around. There we go. And I believe these have a maximum of 4 CPU cores. I can modify this such that people have access to more today, but how many cores do you think people will need?
Okay.
Yeah.
Just do like a basic 128, is it too much?
28?
128?
128 is a lot. 32 is fine.
32.
Yeah, okay. Okay.
If we don't get there, then we know we learn but the hard way, which is, hey, welcome to deep learning.
Yep.
Everything here needs huge amounts of resources.
So I'm gonna do a maximum of 64. I'm gonna stop sharing so that I can do my thing. So give me a minute.
You want to take over and start speaking?
You can speak for a little bit, and I will let you know when the updated machine is ready so people can use.
Okay. Okay, so let's all right. So one of the things we were talking about in last class is we created this where was it, the llama thing. So we created our own chatbot, and if you look at, you can ask it many questions, but there are some places which I was mentioning that if you want this particular chatbot to answer from your own questions for your own data set especially, it is very difficult. So your options are either you take a very big open source model like Llama and fine tune it, which if you realize last week we struggled with CyVerse, not just because of, also because of my lack of knowledge of CyVerse, but it's also because welcome to deep learning, right? Everything here needs huge amounts of resources, which ranges from time, GPU cycles, CPU cycles, hardware, carbon emissions. So, which is why recently people have been inventing something known as RAG, which is called retrieval augmented generation. And I think last week I did a quick primer on how RAG works. So RAG, if you look at the images, probably they will have, beautiful, thank you. The right RAG. But anyway, so this is the image I showed you last time. So which is here, the way we do retrieval augmentation is we take this guy, which is your trained model, ChatGPT or whatever, or Llama. Clearly, you cannot retrain ChatGPT because it's closed, but you can train Llama from scratch. But you don't want to retrain this on your particular data set. Instead, what we'll do is we'll ask a question, and then we will connect it to an index which already has indexed your particular data set. So the idea is, right now, when we were asking Llama questions, Llama is answering from everything under the sun, right? So let's ask something which is very specific to how do I turn on CyVerse? discovery environment. I doubt it knows this unless they have cached it. Either way, we'll find out. It might. So my point is, even to use these kind of big, huge machines in your own data set, using fine-tuning yourself is a bad idea. So today, what we are going to learn about is retrieval augmented generation. And to do that, we are going to share our own Jupyter notebook. Is that what we are doing? It's called sharing a Jupyter notebook? Okay, so do you want to share with them now?
Yes, I have not received any.
Oh, CyVerse. Okay, if you have CyVerse account, can you post your username into the chat channel so that we can share this notebook with you? Close the chat channel. That's okay, I can just open back.
And
okay, why don't you do that while I keep talking?
Yeah,
right.
Can you just mention what you're sharing?
Yeah, so I'm going to share a GPU machine with you all so that we are getting all the right answers or quick turnaround time instead of waiting on all these things to install. So I think we have only one person who has a CyVerse account already, is it? Okay.
Yeah. I know, for example, Chris has an account, so I am invitation now.
Chris Berblinsky. Okay. Cool. So I can keep talking while we do that, right? So I was going to talk about some state of the art in artificial intelligence, of which retrieval augmented generation is one of them. But before that came up, there were a bunch of, okay, this is, we already saw CyVerse. There are a bunch of things like reinforcement learning, RLHF, which is reinforcement learning human feedback. Then there is retrieval augmented generation, chain of thought reasoning. There's a bunch of multimedia techniques. And we will talk about my personal research, which is on quantum NLP. So let me quickly introduce all this, which is, we'll also fine-tune Llama with CyVerse as and when we get there. So here is some theory about what is reinforcement learning. So reinforcement learning is kind of the same idea like your cruise control. So if you remember, this is an example I have been using throughout this class of your cruise control in your car. So how does a cruise control work? So you start with the initial speed, and there is a target speed which the user has set for the machine. Then what the machine does, in this case the car does, is to compare its speed with the target speed, looks for how much is the difference, then it gives a feedback based on how much the difference is. Let's give an example. That assume that currently the car is traveling at 40 miles per hour, and the target speed the driver sets is 45 miles per hour. So what the car does is it finds how much is the difference. So in this case, it realizes I need to add 5 more miles per hour speed. So it goes to the higher channel and says, give feedback to the car. Oh, other way around, lower, right? So it gives feedback to car to increase speed plus n, and n is 5 in this case, right? So this is your standard feed forward and backward propagation, which humans have been using forever. We just keeps showing up in one way or the other. Earlier, it was control systems. Now we have what we call deep learning, and even in the quantum AI, this is exactly the model we use. Deep learning, the only difference is, sorry, question? Oh, so I was saying the question here was, what is lower, equal, or higher? I was saying when a car is initially running at a particular speed, 40 miles per hour, and if the target speed is 45, it will have to lower your speed or increase your speed. I think I mixed up the plus one. So if it, in this case, when it's at 40 and the driver says cruise at 45, it has to increase its speed. And if it's running at 40 and we ask it to cruise at 35, it has to decrease its speed. That's it. So it has to increase its speed to higher or decrease to lower, right? So this is the feedback mechanism that the car has to learn based on a target speed. This is exactly how deep learning works, except in this case, there is a difference that we start with data. The data is, hey, here's something which has whiskers. Here's another thing that barks. Here is a thing which meows. Now, first time when we ask, basically the goal is given a picture of cat or a dog and its features, tell me if it's a cat or a dog. Or primarily, even before we get there, we are training it on, hey, how are you learning this is a cat or a dog, right? So initially, when we give all these data to the deep learning machine, it says, hey, let's predict a random value. And it says, this new picture is a cat. Oh, and you compare with the gold label, which you are, let's say you gave the picture of a dog and you said, nope, it's a dog. So now how much is the difference between cat and dog? Say, for example, one of the differences is dogs don't meow. So they convert that into the math equivalent of it at the embedding level, and they do exactly the same thing. Give feedback to the car based on how much it needs to update its knowledge. And this keeps going on for, what we call thousands of epochs. So in case of GPT, it takes months to train. So that is how a deep learning works. But you should remember, there's no modification to data, or at least the machine, the deep learning tool is not allowed to modify the data. If a human gives it the data that here's a cat, it has whiskers, it meows, here's a dog, it has 4 legs, it barks, the machine is limited with that amount of data it has. It cannot change the data, but with the given amount of data, it can start learning. So people thought, why not allow to modify the data? Why not let the deep learning neural network allow to modify the data, and we'll reward it based on if it's modifying the data correctly. Okay, so the way is we tell them, so this is called reinforcement learning. And the idea is we modify the data. Initially, we gave all this to the machine, which has whiskers, has barks, has 4 legs, has hoofs. And now it's going to slowly modify the data. If it's learning about dog, it's going to remove, if it's learning about, it's learning about dog, it's going to remove it has whiskers. And if it's learning about cat, it's going to remove its barks, et cetera, et cetera. So everything else remains the same, just that now the machine also has access to ability to modify the data. And the idea is we'll maximize the reward while you adhere to a policy. So in this case, the policy is you are allowed to only touch the features of a dog, right? And the machine tries to play around with permutations and combinations. And suddenly it realizes if I remove has whiskers, has meow, oh, suddenly I'm able to predict dog correctly. So that is you're maximizing your reward, and you keep doing this in a huge feed-forward backpropagation loop. And we have what we know as reinforcement learning. Same thing, same idea. You have an agent, which is now your smart AI, and which is going in a feed-forward and backpropagation loop. So in ChatGPT, the equivalent of when we were doing, when OpenAI was initially training ChatGPT, they did that in reinforcement learning human feedback. And the idea was they start with the whole idea that here, collect a demonstration data and train a supervised policy. And what do I mean by that? So they start with the prompt, which is asking ChatGPT, explain reinforcement learning to a 6-year-old. And a labeler, which is a human, demonstrate the desired output behavior, which is we give treats and punishments to teach, et cetera, et cetera. So this data is used to train GPT-5 with supervised learning. And definition of supervised learning is when we have a label telling it if it is predicting a correct thing or not. And now we ask it to just start predicting. And the model says, when you ask explain reinforcement learning, it says in reinforcement learning, the agent is blah, blah, blah. and then it wrongly predicts in machine learning, blah, blah, blah. So it says we give treats and punishments to teach. Assume that some of them are wrong information. So now a labeler, a human being, sits and ranks these output from best to worst. In this case, the best output, the human thinks the definition of reinforcement learning is we give treats and punishments to teach. Okay, so he thinks this is the order of the rate of the power of the answers it retrieved and gave it to you in the first pass, and we sent it back to the machine, and this keeps happening for a long cycle. Now, again, the last time, after it has learned everything about definition of reinforcement learning, we are going to randomly ask, hey, write a story about otters. Now, this machine is so smart at this point that by this exercise of working with human, it has not only learned how to understand what reinforcement learning is, but it has also learned the ability to writing a story. Isn't that wonderful? We just gave it a bunch of examples. I mean, like I said, it probably is explaining reinforcement learning. We might even have given it a story about a king and his horse. But from all that, by doing all this for months, the machine suddenly learns something which is apparently the algorithm which creates any data in the world or any story in the world. And now all you have to ask is write a story about otters. And we still give a little bit of feedback initially, since it's like helping a baby walk. We hold its hand for a bit, and then it takes off, and you have ChatGPT. So let's go back to retrieval augmented generation. Are we ready for that? Or did you give access to people?
I have given access to Rai and Chris.
Okay, and what are we doing in then? Do I go back to my DEs or CyVerse and share it? Okay.
So can I share my screen?
Go for it. Go for it.
So give me a second. Where is my? Yes, there it is. So I have shared with you a couple of running analysis. And what does that mean? Well, this means that these analyses have been started already. And there have been some modifications that Mithun has made. And these are installing specific packages. And so that hopefully you don't have to. You might have to, and I apologize for that, but at least you have access to a GPU. So how do you know where to go for this shared analysis? Up here, you will see a notification bell, which you can click. Excuse me. There's a couple of things in the way. Chris says, I made my own, which is running, but I see the one you shared with me. Fantastic, Chris. Okay, so in order to access a shared analysis, you will see a notification, and in this case, it might say Cosi Michele, share the following analysis with you. So you can go ahead and click that, and it's going to open this. Excuse me, there's too many Zoom windows in front of me. You're going to see this page right here, but this page you have probably seen when you're running an analysis. This analysis was started by somebody else. If you want to join in that analysis, you click on Go to Analysis. So what you should be able to see now is a loading Jupyter lab with a, oh, I believe, is it this one? It's a loaded Jupyter lab with a number of files that you should have access to. It's another question from Chris. Let me download that. Just a second. Yes, Chris, it should look exactly like that. It seems like I have closed mine already. But that's exactly what's supposed to look like. So seems like you are in the right place. I'm going to stop sharing and let Mithun continue.
All right. So I'm assuming you guys are here and are able to access your own Jupyter notebook. So I want you to do two things. One is open a terminal, click on opening a terminal, then also go back here and click on a Jupyter notebook ready to go. So, hey, do you want them to do the force, conda force updating again?
I'll do that. There is a command that there's a couple of commands that you need to run first, and you have access to the commands?
Is it the conda minus force or?
Yeah, I'll type it up. Conda.
You can just put in the chat window.
Yeah, that's what I'm doing.
And do we run it in our home page or do we have to go like home file system or do we go into folders? Doesn't matter.
It's better if you run it right here where they are. It's all good.
Okay.
Yeah. And then they can move the file into their own folder in order to save it. So
is it the share file system where if I type, you can see what I'm doing? No,
no, it's
cannot see anything you're doing. So you're free to do whatever you want in your file system. The operating system is shared with you, and that's all I think we had done, the kernel.
Yeah.
So, and what is the command I need to do to update force, you said?
It's conda update conda.
Conda update conda. Wait, isn't that minus force? Something?
That's where that's when it said that it might be deprecated in the future.
Okay.
But dash force.
Okay, this is the one you said it's going to take conda update.
It's going to take a little bit of time. Force. Yes.
Will adding a minus force help?
No, it should be good.
Okay, so
because it doesn't complain.
While we do that, let's go back to our Jupyter notebook and let's do some pip installs. So if you guys are not familiar what these things are, pip is a global repository where we have a lot of these nice packages kept. If you remember, we had installed everything from pip so far, which is transformers and things like that. But there are some things which are not available on pip, and they are available on another repository known as Conda. And Conda, or Anaconda, if you're not familiar with it, is a nice virtual environment which you can add to any of your command line tools. And I would recommend you go look at Miniconda and try to download Miniconda and start installing Miniconda and try installing it on your machine or even on CyVerse. Okay, actually don't do Miniconda on CyVerse, right? But it's already has Conda in CyVerse. So the idea is we are setting up a virtual environment so that we can slowly install things which we wanted to install. Okay, so it looks like this went along. And another thing I want you to do is when we are here in the same window, now can you do conda install -c conda dash forge FAISS dash CPU. I'll paste this in the chat window in a second. So this is a package known as phase, for example, which they decided we are not going to show it in pip. We would rather upload it in conda. There are numerous reasons for that. I'm not going to get into that. But okay, so now it's saying please update conda. That's needed, right? So we did not update it now. Is that what you're saying?
We updated conda. I don't know why it's giving.
Oh, maybe it doesn't understand the forge part of it. Okay, the conda forge was not updated, which is yet another repository inside conda. So file changed. Christopher is saying it's giving a file change warning. Are they literally using my file?
I mean, you're using untyped.ip. That's your word, and that's someone else.
So how are they getting this? Like they get rag.ipnb.
Yes.
Oh, because they're on my machine.
Exactly.
Ah. Interesting to get this message. So yeah, just click on cancel, I guess. That's weird. Okay.
You can create double, but this is almost at the same time.
So now we are literally sharing the machine with them, but just that we are not sharing the desktop, but you and I are using the same operating system and the same computer almost. Okay, so let's do this conda install -c conda forge face -cpu. And face is one of the CPU is a tool for efficient similarity search for dense vectors. So why are we doing this, right? Remember the idea that we were creating retrieval augmented generation. This is what we're trying to do here. So here, our first step is to install any of these tools which are going to create an index for you. So that is why if you go to face, you'll see that it is creating an index or a clustering of dense vectors, which simply means it is an index. And if you are not familiar with it, we have, if you can search for vector DB, vector databases, and this is the same idea where in RAG, remember we were looking at the database which originally indexes your figure, indexes your data, for example, right? And then this data is indexed in something known as vector DB. So if you look back historically at evolution of computer science, 20 years ago, we had SQL, the querying language, and we were using databases to store and quickly retrieve things from these databases using SQL. But then we moved on, we realized, okay, hey, deep learning is pretty good. Here we have a chatbot which completely understands everything. People were okay until 5 or 3 years ago, because most of the state-of-the-art models you could train locally. But then we ran into the whole idea of large language models, which is not trainable locally. So that's why we are talking about RAG, right? And then somebody realized, hold on, for RAG, we can simply use the same SQL kind of idea when we are trying to install a database, right? It's as simple as this. Like when we saw this picture, now this becomes your SQL query database, and it's called a vector DB, where the data is stored as literally vectors or matrices. And Chroma DB is one of the state-of-the-art DBs, which will help you do that, like essentially index all the data you have. So if you remember, I had shared with you something we developed recently for University of Arizona. This literally sits on top of Chroma DB. It, of course, has a large language model, because if you see in the picture, after we retrieve the question from the Chroma DB, that now we modify the prompt and give it again to the same large language model. For example, if the user had asked, where does the sun rise? And we don't want the ChatGPT to answer the question from the whole internet, but we are going to give it a very small SQL-like database on Jupiter. And maybe in Jupiter, the sun rises in the west. So we now give it the new question in another prompt, which is very similar to something like, hey, dear GPT, use this context I'm providing about Jupiter, and then you answer the question, where does the sun rise? So then this machine is kind of fine-tuned, or in this case, sandboxed within that particular context. And that's how you get these machines to focus on what it's working on. All right. Let's go back and see what happened here. It's all the requested packages installed. Perfect. Let's go back to our Jupyter notebook. Let's start with our standard favorite pip install transformers. And you should also do pip install datasets. Okay, in my case, it's already satisfied, which means I already installed it earlier.
Could you show us what you're running right now?
Oh, the command? Pip install transformers and datasets. Okay, please let me know if there is something that is not working for you. So it looks like it's installed for us already. So we are going to go to the new file and check if all this is installed. And one of the things, From transformers import, remember, we can try auto tokenizer. It doesn't complain, it's a good thing. So in Linux, if it doesn't complain, it's always a good thing. This time, instead of auto tokenizer, we are going to try RAG tokenizer. We also need to get something known as RAG retriever, which is simply the code which is going to retrieve data for you, and RAG token for generation. Let me copy paste this in your command in the text window or chat window. And while it does that, all this is, if you go to Hugging Face, RAG example, you can learn about this in this page here, retrieval augmented generation, right? So the idea is we are slowly creating these models which know how to learn from a data set which we are providing it. Okay, so again, remember, the first thing we do is we need a tokenizer to convert the data, specific data that we are asking. So we do tokenizer equals RAG tokenizer dot from underscore pre-trained. So in this case, we are going to ask a Facebook's RAG. So here, if you look at the RAG, most of the RAG pipelines are provided by Facebook, right? So retrieval augmented generation, because Facebook is into the open source community and they really want to share everything they create. They were nice enough to share all this with us. If you go to Hugging Face models and ask for RAG, everything that shows up is a Facebook RAG, right? Most of them actually. Let's search for RAG, and the top downloaded ones, where does that go? Nope, it's randomly picking your stuff. No, yeah, anyway. Okay, I think Google is also having a bunch of RAGs shared now. I thought earlier when I had looked for most downloads, all of them were, maybe. Now it's changed to, it was, okay, so everybody is giving you a RAG pipeline these days. Anyway, currently we are going to use the Meta's RAG pipeline or Facebook's RAG pipeline. It's called Facebook/RAG token-NQ. So we are using Facebook's RAG pipeline, and we are specifically using the tokenizer from it. Okay, what is it saying? Warning, warning, warning. Not the same as the class. That's okay. So let's do that. And now we need to create a retriever equals RAG retriever dot from pre-trained. So remember, all this is pre-trained and ready to go. All we are doing now is giving it which database or data set you want to work on. Same thing, /RAG token NQ, index underscore. One thing we need to provide is name of the kind of index. So this is index underscore name, type exact for this. Also now we are going to use one of their own data sets instead of giving it our data set, which is already present. So let's call use dummy data set a true, right? So eventually you can replace this with your own data set. So now the next thing is, remember, we usually have tokenizer and the model, but in this case we have a retriever. So we are going to create a model next. Let's see if this works so far. Just warning, so nobody's complaining. Model is now equals to RAG token for generation dot from underscore pre-trained. Same thing, Facebook RAG token NQ. Copy paste the same thing back here. And normally we finished it by here. If you remember in the previous classes, we just give it the token because we are literally using a model. But remember, this time we are using retriever augmented generation. So we need to explicitly give it the retriever. Okay. Once we have this, it's actually learning on a dummy data set. In this case, it's learning from Wikipedia's dummy data sets. So let's see if the dummy data set shows up. Let's Facebook dummy data set. Oh, it's probably going to give me everything in Facebook and not Hugging Face. Yeah, never mind. You can go play with it later. So once we have this data set, first thing we need to do is ask our question. Let's see, where does the sun rise? Now, clearly, this is a very simple, stupid question. In the real use cases, if you are training it on your own, let's say, rare diseases data set, and you can ask the question, what is the name of this rare disease, which if you had asked in our original chat, so remember last week we had created this llama chatbot, and then we were trying to talk to llama using the Gradio. That's how it looks like. So, this time, of course, if you ask about where does sun rise, it's going to answer that. But you see the use case, right? So we are able to train it on our own data sets, and we'll do it in next class. So what you have to do here is we need to create an input dictionary, which uses the tokenizer around what we did earlier, that using the tokenizer which we created earlier. And this command is called sequence to sequence underscore batch. So we're providing it with the command. And there's some other things you need to provide, which is in Aries is the answer I got from for the sun. Okay, but it doesn't answer my question, who is the most famous actor? Oh, okay. So let's see, who is the most famous actor? I'm assuming, Chris, you're talking about all right, this is our guy, which did not work last time. Where did the guy we created? Is it here, right here? No interface is running because our machine shut down. Let's see if the llama is going to run again. But you understand what I'm doing here, right? I'm just using the code from last week to recast it. And apparently, there's definitely questions which the current universal chatbot like llama cannot answer unless you directly plug it into a specified data set of your own choice. So here, you need to provide return underscore tensor as PT. Okay. So now, if you remember, now we have to use the model to generate our output. So model.generate input underscore IDs is the input dictionary we provided. So input underscore dictionary. We have to give it input underscore IDs to pick the exact ID of what we're generating. And we store it in a variable. We don't even know what the variable does, but we find out what the variable does, right? So we print generator. So let's see what this guy does. Something was not closed, which is this guy. And clearly in Python, doing this is a bad idea. Doesn't like spaces or tabs. Ta-da, let's run this. Okay, it's doing something. A lot of warning. Oh yeah, I'm gonna paste this in the chat, sorry, my bad. Yeah, it's boilerplate code, so really nothing interesting. So let's see, where did it go? It game generated is not defined. Okay, where did print generate? Okay, so let's not rerun the whole thing. Let's create a new window and ask it to generate. So it gave you a tensor. So you have no idea what to do with the tensor, right? So the reason is you shouldn't be just printing the tensor. We want it to tell us in English, what does this mean? Remember, this is a generation platform. So we want it to generate the answer for us. And the way you do that is use the same tokenizer, right? And give it the generate and say skip underscore special underscore tokens equals true. And we want the first answer, which is the one which we asked. What did we miss? This is a bracket tokenizer dot batch dot decode. Okay, batch underscore decode, generate skip special tokens true of 0. So there is another bracket missing in Aries. Ooh, where does the sun rise? It rises in Aries. Interesting. What is Aries? So anyway, their dummy data set has taught the machine that sun rises in Aries, whatever that means, right? If you are using your general chatbot, it would have probably said sun rises somewhere, but anyway, more than exactly trying to find the answer of one particular question, which you can, one guy, your general bot cannot do, and your specialized bot can do. The purpose of today's class is to introduce you to retrieval augmented generation and how simple it is for you to connect with a database, like an SQL database. Right, so I will be uploading this in UA DL workshops. I hope you have been going through this. We will upload it on today's, I'm assuming last week we did chatbot over LLM. Today we are supposed to do fine-tune Llama, but then I realized we have the subject matter expert in CyVerse here, so might as well try to do RAG. So I'll be uploading this code here. All right, questions? So let's ask other questions to this guy. Who is the best champion in boxing? Oh, yeah, it's still running. Manuel Char. Okay, I don't know who that is. Meanwhile, I'm gonna run this guy. Let's see who is Manuel Char. Mahmoud Char. Welcome to the world of hallucination. So this is exactly what all of these language models does. It starts hallucinating when it doesn't know the exact answer.
So Mithun, I don't know if you saw my message in the chat, but if you run the actor question.
What's the hallucination and why is it doing it? Okay, perfect. Nice question. So the reason for hallucination is these machines, if you are really a black box for people. So when you're training it on everything under the sun, like internet, you're giving it all these things in the world, and neural networks are really like a newborn baby. And the baby doesn't know the right answer to anything. Now, when you give it a huge thing like Google or internet, it's gonna literally grab straws. Remember, you're trying to teach a newborn baby how to speak English on day one. And which is why it randomly goes and tries to search and find the answers. But the definition is there are no right answers, or at least the kid doesn't know the right answer because we just dumped it with a huge data set. Sometimes it gets it right, but most of the times what happens is it searches for the answer. If it doesn't find it right, it starts making up the answer. So we actually solved this problem last week. Sorry, question? Oh, sorry, Chris was saying something. I think my headphones are off. So in fact, this is something we actually solved this month when we created Chatur. And Chatur is basically same retrieval augmented generation, but internally we specifically gave one prompt to Chatur, which is reply only from the context provided. Else, say you don't know. Don't know, don't make up answers. When we told it to explicitly do this, it stopped hallucinating. So that is, it took us some time to get there, but yeah, apparently you can tell the machine not to hallucinate. All right, well, what was question? Sorry, my question here. We couldn't, sorry. I unmuted the top, but I'm not sure you can hear me. Yeah, sorry. Okay, so you said if you try acting, which actor is the most famous? Let's see, which actor is the most famous? I'm trying to find a good example for all this, which is almost like, what is happening? Okay, so we need to do this guy again. Did we call it generate or generated? Nope, generated. I'm gonna bomb again. Let's go back, copy, paste it under the same place, run the whole thing again. Clear outputs. Okay, it's not even replying. No, it's working. Let's see, doing something. So let's see, meanwhile, if our chatbot got run here, the one we created last week. And if you remember, we did not run this on CyVerse because, hey, you might know the answer to this. this guy, the CyVerse, we were trying to run a chatbot, and CyVerse did not run it because the chatbot is literally hosted on a local host, and we are accessing CyVerse from command line, right? So here, if you look at it, it's going to now spawn a window for a chatbot. It's like chatbot will look like this. It is spawned from localhost. It also gives you an online ID. So we have been surviving with the online ID from CyVerse, but CyVerse was not able to launch it locally. So anyway, oh, wait a minute. I think, no, hold on. I think I solved this. I forgot that I solved that issue. Very smart. Never mind. So if you were in CyVerse last week trying to run our chatbot in CyVerse, we were making one mistake, which was, yeah, I got it to run. I forgot that. We have to just do launch share equals to true. So once we run that, it shows you this chat window in CyVerse itself. All right, we are officially done with the class because I'm just trying to rerun the whole thing from last week. Sorry. Yeah. Okay, any questions?